can the general sort of robotics, the epitome of the robotics problem, be solved purely through learning, perhaps end-to-end learning, sort of learning from scratch, as opposed to injecting human expertise and rules and heuristics and so on?
I think that in terms of the spirit of the question, I would say yes. I mean, I think that though in some ways it's maybe like an overly sharp dichotomy. Like, sure. I think that in some ways when we build algorithms, at some point a person does something. Like
hyperparameters. There's always
a person turned on the computer. A person, implemented TensorFlow. Yeah. But yeah, I think that in terms of the point that you're getting at, I do think the answer is yes. I think that we can solve many problems that have previously required meticulous manual engineering through automated optimization techniques. And actually, one thing I will say on this topic is I don't think this is actually a very radical or very new idea. I think people have been thinking about automated optimization techniques as a way to do control for a very, very long time. And in some ways, what's changed is really more the name. So, today we would say that, oh, my robot does machine learning, it does reinforcement learning. Maybe in the 1960s, you'd say, oh, my robot is doing optimal control. And maybe the difference between typing out a system of differential equations and doing feedback linearization versus training a neural net, maybe it's not such a large difference. It's just, pushing the optimization deeper and deeper into the thing.
Well, it's interesting you think that way, but with especially with deep learning, that the accumulation of sort of experiences in data form to form deep representations starts to feel like knowledge as opposed to optimal control. So this feels like there's an accumulation of knowledge through the learning process.
Yes. Yeah. So I think that is a good point. That one big difference between learning-based systems and classic optimal control systems is that learning-based systems, in principle, should get better and better the more they do something.
Right.
And I do think that that's actually a very, very powerful difference.
So if we look back at the world of expert systems and symbolic AI and so on, of using logic to accumulate expertise, human encoded expertise, do you think that will have a role at some point? So deep learning, machine learning, reinforcement learning has shown incredible results and breakthroughs, and just inspired thousands, maybe millions of researchers. But there's this less popular now, but it used to be popular idea of symbolic AI. Do you think that will have a role?
I think in some ways, the descendants of symbolic AI actually already have a role. So, this is the highly biased history from my perspective. You say that, well, initially we thought that rational decision making involves logical manipulation. So you have some model of the world expressed in terms of logic. You have some query, like what action do I take in order for X to be true, and then you manipulate your logical symbolic representation to get an answer. What that turned into somewhere in the 1990s is, instead of building kind of predicates and statements that have true or false values, we'll build probabilistic systems where things have probabilities associated with them, probabilities of being true and false, and that turned into Bayes nets. And that provided sort of a boost to what were really, still essentially logical inference systems, just probabilistic logical inference systems. And then people said, well, let's actually learn the individual probabilities inside these models. And then people said, well, let's not even specify the nodes in the models. Let's just put a big neural net in there. But in many ways, I see these as actually kind of descendants from the same idea. It's essentially instantiating rational decision-making by means of some inference process and learning by means of an optimization process. So in a sense, I would say, yes, that it has a place. And in many ways, that place is, it already holds that place.
It's already in there. Yeah, it's just by different. It looks slightly different than it was before.
Yeah, but there are some things that we can think about that make this a little bit more obvious. Like if I train a big neural net model to predict what will happen in response to my robot's actions, and then I run probabilistic inference, meaning I invert that model to figure out the actions that lead to some plausible outcome. Like, to me, that seems like a kind of logic. You have a model of the world, it just happens to be expressed by a neural net, and you are doing some inference procedure, some sort of manipulation on that model to figure out, the answer to a query that you have.
It's the interpretability, it's the explainability, though, that seems to be lacking more so because the nice thing about sort of expert systems is you can follow the reasoning of the system that to us mere humans is somehow compelling. It it's just I don't know what to make of this fact that there's a human desire for intelligent systems to be able to convey in a poetic way to us why it made the decisions it did, like tell a convincing story, and perhaps that's like a silly human thing. Like we shouldn't expect that of intelligent systems. Like we should be super happy that there's intelligent systems out there. But if I were to sort of psychoanalyze the researchers at the time, I would say expert systems connected to that part, that desire of AI researchers for systems to be explainable. I mean, maybe on that topic, do you have a hope that sort of inference systems, so learning based systems, will be as explainable as the dream was with expert systems, for example?
I think it's a very complicated question because I think that in some ways the question of explainability is kind of very closely tied to the question of like performance. Like, you know, why do you want your system to explain itself? Well, so that when it screws up, you can kind of figure out why it did it.
Right.
But in some ways that's a much bigger problem actually. Like your system might screw up, and then it might screw up in how it explains itself, or you might have some bug somewhere so that it's not actually doing what it was supposed to do. So, you know, maybe a good way to view that problem is really as a problem, as a bigger problem of verification and validation, of which explainability is sort of one component.
I see. I just see it differently. I see explainability. You put it beautifully. I think you actually summarized the field of explainability. But to me, there's another aspect of explainability, which is like storytelling.
Hmm.
That has nothing to do with errors or with like the sort of it doesn't it uses errors as elements of its story as opposed to a fundamental need to be explainable when errors occur. It's just that for other intelligent systems to be in our world, we seem to want to tell each other stories. And that's true in the political world, that's true in the academic world, and that neural networks are less capable of doing that, or perhaps they're equally capable. Storytelling is storytelling. Maybe it doesn't matter what the fundamentals of the system are. You just need to be a good storyteller.
Maybe one specific story I can tell you about in that space is actually about some work that was done by my former collaborator, who's now a professor at MIT, named Jacob Andreas. Jacob actually works in natural language processing, but he had this idea to do a little bit of work in reinforcement learning, and on how natural language can basically structure the internals of policies trained with RL. And one of the things he did is he set up a model that attempts to perform some task that's defined by a reward function, but the model reads in a natural language instruction. So this is a pretty common thing to do in instruction following. So you tell it, like, go to the red house, and then it's supposed to go to the red house. But then one of the things that Jacob did is he treated that sentence not as a command from a person, but as a representation of the internal kind of state of the mind of this policy, essentially. So that when it was faced with a new task, what it would do is it would basically try to think of possible language descriptions, attempt to do them, and see if they led to the right outcome. So it would kind of think out loud, like, I'm faced with this new task. What am I going to do? Let me go to the red house. Oh, that didn't work. Let me go to the blue room or something. Let me go to the green plant. And once it got some reward, it would say, oh, go to the green plant. That's what's working. I'm going to go to the green plant. And then you could look at the string that it came up with, and that was a description of how it thought it should solve the problem. So you could basically incorporate language as internal state, and you can start getting some handle on these kinds of things.
And then what I was kind of trying to get to is that also if you add to the reward function the convincingness of that story. So I have another reward signal of like people who review that story, how much they like it. So that, initially that could be a hyperparameter, sort of hard-coded heuristic type of thing, but it's an interesting notion of the convincingness of the story becoming part of the reward function, the objective function of the explainability. It's in the world of sort of Twitter and fake news, that might be a scary notion, that the nature of truth may not be as important as the convincingness of how convincing you are in telling the story around the facts.